Big muscles are highly desired for their physical benefits to the structure of the body and bettering one's overall physique. Do you ever just sit back and wonder how the body builds this muscle? Hello, my name is Hellstrom, and I'm here to talk about how muscle develops. Muscles come in 3 different categories, such as cardiac, smooth, and skeletal. But for the purpose of this presentation, I will only be discussing skeletal. Skeletal muscles are attached to bones by tendons and can be controlled by the nervous system. Today, I will explain the biological process of muscle development, the specific functions of skeletal muscles, and the differences between myofibrillar and sarcoplasmic hypertrophy. The human body follows a specific process in making new skeletal muscle. The 2 key components of this process are protein synthesis in the form of myofibrils and cellular repair. It begins with the original muscle being torn due to the strain from lifting weights and exercising. This creates a feeling of soreness because the muscle is damaged and requires healing. Here, satellite cells, which have been dormant on the exterior of the muscle tissue, are activated and rush to the site of the tear. These satellite cells move into the damaged areas and multiply rapidly with the help of the body's amino acids. As these cells divide, they create new muscle protein fibers, or to attach to other damaged fibers, also known as myofibrils, which are made up of protein strands and are used for repairing damaged fibers and growing new fibers. The result are new myocytes or muscle cells, as well as new muscle protein. The entire process is called hypertrophy, which is the enlargement of an organ or tissue by increasing the size of its cells. Ending this process, the body now has the muscles that are bigger and stronger than before. Now that I've explained the process of muscle development, I will now discuss the specific function of these skeletal muscles. Helping the overall physical function of the body is the skeletal muscle's main priority. Alongside this general goal, the skeletal muscle is highly associated with support, movement, and homeostasis of the body. Skeletal muscles contribute to the posture and the position of the body as well. They also allow for contractions between tendons and bones. As the muscle shortens, the body is propelled into motion. Another function of the skeletal muscle is keeping the body in a state of homeostasis, which is a constant temperature of 98.6 degrees Fahrenheit. As the muscle contracts, heat is left off as a byproduct, and the heat is used to stabilize the body's overall temperature. Combining all 3 of these functions, the skeletal muscle keeps the body's physical functioning in prime conditions. After talking about the specific functions of skeletal muscles, I will be talking about the differences between myofibrillar and sarcoplasmic hypertrophy. Myofibrillar hypertrophy is the process of muscle growth through contractile proteins in order to create new muscle cells. This is seen as the best way to build muscles for athletes because it allows the muscle to be the most functional. Sarcoplasmic hypertrophy involves non-contractile proteins and creates plasma, which allows for the swelling effect in the muscle. The muscle seems larger than it can actually perform with. This is seen most in the muscles of bodybuilders because the muscles are mainly for show and not to actually improve body function. Now that I have talked about how muscle is developed, the specific function of muscle cells, and the differences between myofibrillar and sarcoplasmic hypertrophy, I hope you understand, while working out, what internally your body is doing to increase the growth of the muscles. This knowledge is key to maximizing muscle growth, maintaining a healthy body, and having an overall understanding of how the body works. Thank you for listening to my presentation.